In this video, we're going to look at an exam question involving impulse. Now, in its simplest sense, impulse is the sort of product of a force acting multiplied by time. Unfortunately, in this question, the force that's acting is a variable force. This t cubed plus t is the force acting. So the force acting actually depends on time. So when force is variable, we work out impulse using integration. So the integral is impulse is the integral of force with respect to time. Okay, that's the sort of formula for impulse. In our example, we're integrating the force is t cubed plus t, and this force is acting between 0 set t equals 0 and t equals 4. So we have to do this integration between time 0 and 4 of t cubed plus t with respect to t. Okay, and if we integrate t cubed plus t, we get t to the 4 over 4 plus t squared over 2. Again, between 0 and 4. The upper limit of that is 4 to the 4 over 4 plus 4 squared over 2. And then the lower limit is, well, when we substitute 0 into our integrand, we just get 0. So we end up with 4 to the 4 over 4, which is 64, plus 16 over 2, which is 8. So this is 72. And the units of impulse are kilogram meters per second, which is actually the same as Newton seconds. So either kilogram meters per second or Newton seconds are both appropriate units for impulse. And that's my answer. Impulse is 72 kilogram meters per second. Okay. For part B, it asks us to find the speed of the particle when t equals 4. Well, there's another formula for impulse. Impulse equals mass multiplied by the change in velocity. Well, we've just worked out that the impulse was 72, and we know that the mass here, we're told the mass of the particle is 0.5. So that means the change of velocity can be worked out. 72 divided by 0.5, that is 144 equals my change in velocity. Well, because the particle was initially at rest, so the initial velocity was 0, and the change in velocity is 144, that means final speed equals 144 meters per second. Okay, so that one's a little bit easier. We just need to know that impulse is mass multiplied by change in velocity. Okay, and the final question is, I guess, the hardest one. Find the time taken for the particle to reach a speed of 12 meters per second. Okay, so actually in this question, we're almost going to combine the two formulae that we used in parts A and B. So let's have another look at this. So C. Okay, now we're reaching a speed of 12 meters per second. So remember, impulse is mass time to change in velocity. So the impulse in part C is mass 0.5 times the change in velocity. Well, if we start at 0 and end at 12, the change in velocity is 12. So the impulse in part C is 6 kilogram meters per second. And now we need to use the formula from part A, which is that impulse equals the integral of f dt, which is the integral of t cubed plus t dt. And that's we're starting at time 0, but now we don't know what time we finish at. So we're going to use a capital T to denote our finishing time. And this impulse, we know, is equal to 6. So the integral between 0 and our final t of f dt is equal to 6. And now we just need to solve this to find t. Well, the integral becomes t to the 4 over 4 plus t squared over 2 between 0 and capital T, and that's equal to 6. Now the left-hand side is just t to the 4 over 4 plus capital T squared over 2 minus 0, which is the lower limit just of 0, equals 6. And we have to solve this equation to find out what capital T is. So how do we solve this to find what capital T is? Well, let's rearrange it and multiply through by 4. We get t to the 4 plus 2t squared minus 24 equals 0. Rearranged and multiplied everything by 4. Now this is a quadratic in t, in capital T squared. So we solve it using the quadratic formula, and we get that t squared equals minus b, so that's minus 2, plus or minus the square root of b squared, 2 squared, minus 4ac, so that's plus 4 times 24, over 2a, so that's over 2. Simplifying this, we get minus 2 plus or minus the square root of 100 over 2. And this gives two solutions. We get either 4 or minus 6. Okay, well, minus 6 is not a solution because this is t squared, and t squared can't be a negative number, so that means that our only solution is t squared is 4. T squared equals 4, which implies that t equals plus 2 or minus 2. Well, minus 2 is impossible because we're not going backwards in time, so that's not our solution. So our time is 2 seconds.